First described in Sir Isaac Newton's 1687 book, Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, his three laws of motion describe the relationships between the forces acting upon objects and the motion of those objects. The first law states, paraphrased from Latin, that an object will remain at rest unless acted upon by an outside force, while an object in motion will remain in motion in a perfectly straight line unless also acted upon by an outside force. A ball sitting on a table will remain stationary unless bumped or hit. Conversely, a ball that is thrown will continue on in a straight line until influenced by other forces. On Earth, the two most common types of forces that affect motion are friction, in this case, friction against the air, and gravity. If all of the forces acting upon an object, whether one at rest or in motion, cancel each other out, this is the same as no forces acting upon the object. In this situation, the object's motion, or lack thereof, will not change. The name given to an object's resistance to changes in its motion is called inertia. The second law of motion, when translated, states that an object's acceleration is dependent on the mass of the object and the force applied to that object. This can be expressed by the equation F equals ma, or force equals mass times acceleration, where m is measured in kilograms, a is measured in meters per second squared, and the resulting force is measured in newtons, the namesake of Sir Isaac Newton. In other words, a force applied to an object will cause that object to accelerate, and the amount of acceleration imparted will be proportional to the amount of force. There is also an inverse relationship between the object's mass and the amount of acceleration it will receive. A lighter object will accelerate more than a heavier one if the applied force on both is equal. The third law of motion states that an object that exerts a force on another object will have an equal and opposite force exerted upon it by the second object. In other words, for every action, there is an equal and opposite reaction. In a rocket launch, for example, the rocket's thrust is the reaction generated from the action of expelled exhaust caused by the combustion of fuel. Another example is that of gravitational force. A person, or indeed any other object, simply standing still on Earth's surface, is pulled toward the Earth by its gravity. At the same time, the object, though having a minuscule gravitational pull in comparison, still exerts its own pull upon the Earth. Forces, therefore, appear in pairs. Though other models, such as relativity and quantum mechanics, have replaced Newton's laws as more fundamental descriptions of the physical world, the three laws of motion discussed here still give an accurate picture of the activities of everyday life and provide an important basis for other, more complex theories.